Hi everyone, really quick video here going through velocity time graph. So let's jump straight in. So on the left hand side you can see here we've got velocity on the bottom. On the x-axis we've got time. So velocity is in meters per second, times in second. You've got a nice curve here, and the first question here says find the estimate for the acceleration at 3 seconds. So you go to 3 seconds and you put a point. What you then need to do is draw a tangent line, like I've done there, at that point. So when you see a velocity time graph and it asks you for acceleration at a particular point on a curve, draw a tangent line. What you then need to do is think about the fact that you've got to find the gradient of this line. So to find the gradient of a line, you do change in y divided by change in x. Be careful to make sure you get that the right way around and not x over y, it's y over x. You can see my change in y here goes 5, 10, 15, 20. Be careful of your scale. And my change in x goes 6. So what you need to do is pick 2 points on this line. Doesn't matter what 2 points you choose because it is an estimate, but just make sure you can read your scale correctly. What I'm then doing is 20 divided by 6, which is what you can see I've done here. 20 over 6 turns to 10 over 3, and then that 3 goes into 10 3 times with 1/3. So your acceleration is 3 1/3 meters per second squared. Acceleration is measured in meters per second squared. So if you're asked to find acceleration at a point on a curve, draw a tangent, find the gradient. The next thing you could be asked about velocity time graphs is this bit here, and it says work out an estimate for the distance covered. Well, to find the distance in a velocity time graph, all you need to do is this whole area here, you need to find the area of it. So what I do there is split it into shapes. The more shapes you split it into, the more accurate it will become. But you can see I've got a triangle. Generally speaking, you'll have another trapezium in the second part, and then there'll be rectangles and triangles as well. So part A is base times height divided by 2. This one is the trapezium, so it's A plus B times the height and then divided by 2. Here's a rectangle, just base times height, and D is a triangle, base times height divided by 2. So you can see all my working out here. I've done that. So then when you find each section, which is what I've done here, you then add them all together and you end up with 390. 390 meters is therefore an estimate for the area covered. Now that is an underestimate because you can see here I've not actually included that part, and there's a little slither here I haven't included. So when you're working out, it will generally be an underestimate. So a couple of things to remember. First, to find the distance, you find the area underneath the shape, split it into different sections and find that. And then here, to find the acceleration at a particular point, draw a tangent, find the gradient of that line. So that is velocity time graphs. Nice and quick recap. Hope it helps you. Hope you found it useful. See you on the next video.